Hello everyone, welcome back to Physics Knowledge YouTube channel. Today we will discuss one of the most important discovery in the history of physics, that is Oersted Discovery. Yes, the moment when electricity and magnetism came together for the very first time. By the end of this video, you will clearly understand the experiment, the observation, the conclusion that changed the science forever. So let's begin it. Listen, before Oersted, what happened? Scientists used to think that they believe that there is no relationship between electricity and magnetism. I mean, they used to think that both are separate. Both are two separate things. Like if we need electric field, so I will go with charge. Charge produce electric field. But if I need magnetic field. So for that, magnet is enough. Okay, na? And a magnet provide magnetic field and the charge provide electric field. I mean, electricity and magnetism, both were two different things. In fact, this Oersted also initially, he also used to think that there is no relation between these two, I mean electricity and magnetism. And for that, he used to place one needle, compass needle, nearby a conductor carrying current, but it was placed perpendicular to it, so no deflection. So he thought that there is no relation at all between electricity and magnetism. Okay, but one day, one strange thing happened to himself. So what happened that day, that we will discuss in this video, right? So this is what I am talking about, Oersted discovery, the first known experimental evidence for the relationship between electricity and magnetism. तो दोस्तों क्या होता है आइए देखते हैं, ठीक है। तो ये कहानी शुरू होता है 1820 में। कब होता है? 1820, 1820 ईस्वी में। आई एम नॉट टॉकिंग अबाउट 1920, इट्स अबाउट 1820. It's 1820, not 1920, 1820. So in 1820 what happened? That completely changed the world. See what we have, almost all the devices that we are using at present, I mean generator, motor, this wireless telecommunication, right? MRI machine, so many things are there, so many electronic devices are there that we are discussing and that we are using in our day-to-day life, that all begin with the experiment that starts with Oersted discovery. So that is very very important बच्चों, ठीक है। तो चलिए शुरू करते हैं। See, Hans Christian Oersted, one Danish scientist was there, I mean physicist was there. Okay? In 1820 what happened? See, it was he who initially used to believe that there is no relationship between electricity and magnetism. So for that, what he used to do, he used to place a compass needle. But ये compass needle है, we have already discussed. There is a compass showing direction consists of needle magnet pivoted at the middle. That structure is called compass needle. Okay na? So there in this compass, magnetic compass, one needle is there, needle magnet is there. Okay, it is generally made up of steel, right? And it is magnetized steel. Okay, so that it will show the north-south direction. Okay, so this was placed nearby a conductor carrying current, showing no deflection. Why no deflection? Because it was placed perpendicular to it, right? But one day, what happened during his lecture, he placed the setup. He did a during his lecture, in his setup, see I'm showing you the setup also. Okay, what he did, he placed a conductor carrying current, okay, above the this magnetic needle, okay, but it was placed parallel to it and shows deflection, right? So this was completely unexpected, strange thing happened with himself, with this Oersted, right? So by mistakenly this discovery came to us, right? Okay, so again I repeat, in 1820 what happened? Professor of physics in Copenhagen, capital of Denmark, a Danish physicist, during his lecture he saw that when a compass needle was placed parallel to a conductor carrying current, it is showing deflection. When the current is stopped, okay, so this is the positive terminal and this is the negative terminal. The current is going like this and showing deflection. I am showing you a diagram also. You see, on further investigation, he found that this deflection, okay, depending on the current, when the current is in upward direction, suppose this is the positive terminal and this is negative terminal, and this is how the current is going. It is showing north pole toward left side. Again, in this figure, what happened? The compass needle is placed above the conductor carrying current, okay, and the current is going in this way. So this time the deflection is there. This is north pole. Here it was north pole. So this time this north pole deflected toward right. Current is in upward direction only. So this is how. This is also positive terminal. This is negative terminal. The current is going from positive to negative. Now what happened? On further investigation, he found that दिस डिफ्लेक्शन जो है नॉट ओनली डिपेंड अपॉन द current, in fact it is depending position also. It depends on position also, whether this compass is placed above or below the conductor carrying current. See here, so current was there, okay, so one time current was going in upward direction. Here we have reversed the current, okay, and with the direction of current, I am showing you in one case when the position is downward, I mean when the position is below the conductor carrying current and the position is above the conductor carrying current. Same we have done with this when the current is in downward direction, and in one case I have shown you when the needle is in when the compass needle is below the conductor carrying current, and here the compass needle is placed above the conductor carrying current. In all the cases we have seen the deflection in different manner. I mean it is showing a pattern, right now it is showing a pattern. So this resemble a pattern. So finally the main conclusion of Oersted discovery is that around a conductor, suppose this is a conductor which carry some current, okay? So around a conductor there is a magnetic field, right? There is a magnetic field. I mean if suppose this is a conductor, here magnetic field is there, here magnetic field is there, below the magnetic field there, left, right, है ना, front, back, everywhere जो है all around जो है magnetic field is there, right? So understood what happened in 1820. प्रोफेसर ऑफ फिजिक्स आते हैं जो कि कोपेनहेगन में है ना, डेनमार्क कैपिटल जो है डेनमार्क है, प्रोफेसर ऑफ फिजिक्स इन कोपेनहेगन कैपिटल ऑफ डेनमार्क. इन 1820 what happened, he initially used to believe that there is no relationship between electricity and magnetism, and for that he was showing this setup showing no deflection, right? This setup means this was the setup, ठीक है, but it was placed perpendicular to the conductor carrying current, showing no deflection. But one day such an incident happened to himself. This deflection was placed perpendicular to the conductor carrying current, it was placed parallel to the conductor carrying current, and so is the deflection. So by mistake this happened, right? And now we have the miracle. Now this completely changed the science forever, okay? So in further investigation he found that this deflection जो है depending upon the direction of current as well as depending upon the position also, I mean position itself, ठीक है? So finally he observed and conclude something. So what we have with the conclusion of this Oersted discovery, ठीक है, we have, see I have written here the conclusion. Number one, a current carrying conductor जो है always produce magnetic field. A current carrying conductor always produce magnetic field, right? A current carrying conductor always produce magnetic field. That only we are discussing as of now, that a current carrying conductor can behave like a magnet, right? So this is one of the most important and final conclusion of this Oersted discovery. The main conclusion of this Oersted discovery is this only, right? What? Around a conductor carrying current there is a magnetic field. Suppose if this is a conductor which carry some current I, so around this conductor which carry current I there is a magnetic field, right? Around this conductor there is a magnetic field. I mean a conductor carrying current behave like a magnet. So this was the main conclusion of this Oersted discovery, right? So with this what we came to know, secondly we see that this is circular in shape. You can see here, means around a conductor left, right, front and back, ठीक है, in a backward direction, in upward direction, left side, right side, everywhere जो है this directional current is there, I mean directional magnetic field is there. So this is circular in shape. So what we discussed firstly I am saying that around a conductor carrying current there is a magnetic field. Secondly I am saying it is circular in shape, right? Third what I have written, perpendicular. I mean this field is perpendicular to the conductor carrying current. यानी ये जो कंडक्टर है, कंडक्टर जो कि करंट को कैरी कर रहा है, इसके ये जो फील्ड है ये परपेंडिकुलर है, आप देख सकते हो, है ना, जो फील्ड है ये परपेंडिकुलर है, ठीक है ना, ये कंडक्टर है, कैरिंग करंट है, एंड दिस इज द फील्ड, दिस टू आर परपेंडिकुलर टू ईच अदर, राइट. थर्ड वी हैव नोटिस दैट इट इज डायरेक्शनल, I mean this directional only leads this Snow rule, that right hand thumb rule, ठीक है, एम्पेयर स्विमिंग रूल दैट वी आर कंसिडरिंग. वी विल डिस्कस दिस ऑल रूल आफ्टरवर्ड, आई मीन आफ्टर दिस लेक्चर, दिस स्ट्रेट कंडक्टर कैरिंग करंट. फॉर दैट आई एम मेकिंग सेपरेट वीडियो. Here this directional means how to find out the direction of this magnetic field due to a straight conductor carrying current. So for that we have a right hand thumb rule. Imagine a conductor in your right hand in such a way that if your thumb will represent the direction of current, then the direction of curling of your finger, this one, will represent the direction of magnetic field. I mean, if this is a conductor showing a current in this direction, then this is how you can find out the direction of current, I mean direction of magnetic field. So below the conductor, the field will be this side. Above the conductor here, the field direction of field will be, this is how, toward right. And here if someone will ask you what is the direction of magnetic field around this conductor carrying current at this point, I mean right to this conductor carrying current, so this will be this side. And again here at this point, what will be the direction of current, I mean direction of magnetic field using this right hand thumb rule. So this is how, this side. So don't you see this is circular, right? This is circular. This is how, I mean direction will be this, like this, in anti-clockwise direction. So this is how it is. Okay, it is reverse direction. Reverse direction in the sense when we reverse the direction of current. See, here the direction was in upward direction. When the direction of current was reversed, I mean here suppose this, you will make this negative positive direction, and this you make it negative direction, and this is how the current is coming. So you can see the deflection is in opposite side. This is this was the case when the direction of current was in this direction and deflection was left side. Okay? And here also the conductor carrying current is above the needle. Here also it is above the needle. Needle के ऊपर है ये conductor carrying current. Needle is below the conductor carrying current. Okay? So this compass needle is placed here below the conductor carrying current. Here also below the conductor carrying current. But here जो है deflection is toward left. But here we are getting the deflection toward right. Understand? So this was completely the observation observed by Oersted. Okay? He conducted a series of experiments, okay, in order to just find out what is the relation, what is the exact relation. So further and further he investigate, further and further. On further investigation he found this much, and now we have the conclusion. So what we have seen, the conclusion: a conductor carrying current always produce magnetic field. Okay? It is perpendicular to the conductor carrying current. यानी ये जो मैग्नेटिक फील्ड है, ये जो मैग्नेटिक फील्ड है ये कंडक्टर कैरिंग करंट के परपेंडिकुलर होगा. ठीक है. दूसरा इट इज सर्कुलर होगा, ये सर्कुलर इन शेप. ठीक है ना. और उसके बाद ये डायरेक्शनल होगा, मतलब इसकी डायरेक्शन होगी, नहीं कि जैसे जैसे मैग्नेटिक फील्ड होगी तो वही डायरेक्शन हम लोग राइट हैंड थंब रूल से निकालते हैं. स्नो रूल भी है, स्नो रूल, एम्पियर स्विमिंग रूल. ठीक है. इमेजिन यू आर स्विमिंग, showing your head जो है in a direction of current, then the left side, I mean your left hand, direction of left hand will indicate the deflection of compass needle. See, left side. This is how it works. Snow rule. Maxwell screw rule also. The screw is if the screw is rotating in anti-clockwise, it is coming upward. So direction of current is in upward direction, then it will, the deflection, I mean the direction of magnetic field will be in anti-clockwise. This is how also you can remember this. ठीक है. Okay. Now next we have written strong. अच्छा, ये strong से क्या मतलब है? Strong means we see that when the current is increased here, it is seen that when the direction of current is increased here, ठीक है, the deflection also we are getting. It reflect in deflection also. I mean, if the direction of current is increased, then deflection also become then we are seeing the effect in deflection also, right? So these are the conclusion बच्चों. ठीक है. And after this only we have the complete जो है this only lead the birth of electromagnetism. और इसका ये बहुत बड़ा रोल है बच्चों. ये जो 1820 से शुरू हुआ ना, 1820 से, और इसके बाद से आज के डेट में हमारे पास जो whatever almost all kind of devices we are using at present, almost all the electronic devices, in fact this huge network of telecommunication, wireless communication, all जो है could start with this Oersted discovery only. So this is very very important बच्चों. This is important for board exam class 10 also. ठीक है. So stay tuned. I hope it is clear to all. Thank you so much everyone.